Okay, class, let's continue with third part of the video with determinants. Okay, let's see what is determinants. An important concept in normalization is something called determinant. Determinant, a field or a group of fields that controls or determines the value of another field. From the previous example, the value of email will determine the values in the other tables or other fields. For example, like one particular ID able to determine the other details about a person. For example, like we have IC numbers, right, as our unique ID. So from the IC number alone, we're able to identify what is our address, our contact number, our email address, our parents' details, our educations, and whatever details which is related. So here, the IC number acting as a determinant in order to determine the other groups of fields. A determinant must return only one value. For example, given student ID ABC 123456, how many name, date of birth, IC number will you retrieve? Based on your student ID here, for example, here we have student ID. So how many name, date of birth, IC number will you retrieve? When you have a name, Lima Cow, how many student ID, date of birth, IC number will you retrieve? So which is the determinant here? Student ID or name? Okay, in this case, I would say that student ID will be the determinant. Lima Cow is not a determinant because one ID belongs to only one person or one student. Okay, just imagine that every student in our classroom, they have their own metric number, right? So which means that they are quite unique for everyone, every individual. So based on the student ID alone, we can determine the name of the student, date of birth, and IC number. But when it's come to Lim Akau, there is a possibility that the same name, same spelling present in a database for multiple times. So in this case, name cannot be the determinant. Functional dependency. Determinants are based on the concept of functional dependency. Functional dependency in general are determinants. Also, I would say that in general, like primary keys of a table. So functional dependency occurs when the value of one set of attributes determines the value of the second attribute. For example, student ID determines the student name. So one student ID will return one student name because student ID is unique. Student ID able to determine dorm name, dorm room, and fee. So one student ID will return one dorm name, one dorm room number, and one fee as well. So the attribute on the left side, so this one is the left side and this one is your right side. So the left side of the functional dependency is called the determinant. So these are the determinants. Okay, these are known as determinant. And this determinant determines the student name, dorm room number, and also the fee. Okay, functional dependencies may be based on an equations, but they are not equation. They say may be based on equation, but they are not equation. Remember this. Extended price is equal to quantity times unit price. But so which means that extended price is determined through quantity and unit price. They are not equal, which means that unit and quantity is required to determine extended price. So in this case, the functional dependency will be quantity or unit price, or it's known as determinant. So just skip the previous example. Let me just go with the next example. Composite determinant, a determinant of a functional dependency that consists of more than one attribute. Like example, the previous example here, quantity and unit price, they are actually known as composite determinant or composite key. Composite key means I already explained during ERD time. We have two primary key in a table. They are known as composite key. One single primary key, we just normally call that as a primary key alone, a primary key. Okay, when we have two primary key in the table, in the same table, so we call them as a composite key. So in this case, student ID and course code required together. Remember class, together, they must be joined together to determine the grade. Okay, let's come back to the example below here. Student name, for example, this one is student ID and not name. Student ID ABC1234 for the course code AACS 3013 and the grade is E. So in order to determine the grade, course code alone, okay, for example, we have 3013 and 3013 got two, okay, two rows with the same course code. So one got A, the other one got B plus. But who got A and who got B plus? How you determine that? I mean, how do you identify that? Who got A and who got B plus? So in order to determine who got A and who got B, we need another joint determinant, which is student ID in this case, okay, joined together with course code to determine the grade of the subject. I hope you guys can understand the meaning of composite determinants. Okay, so these are the functional dependency rules. We already learned these in maths. Remember, recall back your form 4 maths. We learn about semantics. Okay, the implications and conclusions. What makes determinant values? Determinant values are unique. Determinant is unique in a relation if and only if it determines every other column in a relation. For example, you have a table and first column is the primary key. Okay, just imagine this is a primary key. So this can determine another columns, another column, another column, another column. So they are known as unique. You cannot find the determinants of all functional dependency simply by looking for unique values one column. So there are some limitations as well. Okay. Relational database design. The concept of keys are very important. A key is a combination of one or more columns that is used to identify rows in a relation. And a composite key is a key that consists of two or more columns, okay, as a key determinant. That is what we call as composite key. Candidate key is the key that determines all the other columns in a relation, but there can be more than one candidate key as well. For example, student ID, C number, driving license number as a raw data, as a row in a table. So there can be any other attributes that can be acting as a candidate key. So they are known as who can acting as a primary key of the table. So they are known as candidate key. So primary key, I guess you guys know already. We have a surrogate key. I don't want to touch on this. Foreign key, you already know. Foreign key is the primary key of one relation that is placed in another relation to form a link. So you have a two table connected to another table. Remember, usually one-to-many relationship. So the primary key here will be passed to another table to join as a foreign key, and it always primary key here and then only go to foreign key here. If it is relation to one to many, bring this primary key into this table 1, table 2. From table 1 to table 2, the foreign key should be placed. You cannot place foreign key here, primary key here. You can have this primary key also here. There's one primary key in both table, but this primary key cannot be as a foreign key in this table because we cannot write in the reverse. One to many means we have to follow from here to here, left to the right. And in DBDL format, this one is DBDL format. This is what we call as DBDL format, database design language format. We write in this way: table name, underline the primary key, and other attributes. If you have a foreign key, you have to make sure you put asterisk or star symbol. So this is how we write the referential integrity constraint in SQL. Foreign key, okay, you declare author ID, okay, author ID as the foreign key as well, okay, also acting as a primary key because it's a many-to-many relationship table which has been solved. So that's why they have a same primary key and same foreign key. So this foreign key author ID, which is referring to author table, we have another table which is created before, and there is an author ID as well. So we make sure that the attribute same spelling, same size number as well, the data type. If varchar 11, you must make sure that inside the author table also it's varchar 11, otherwise it will cause an error again. So you violate the integrity constraint. Okay, so this is an example: determinants and duplicates data. So here in this case, email act as a determinant because email is underlined primary key. So email determine the first name, email determine the last name. So one person can have one unique email ID. You cannot have the same email ID for two person, remember. Okay, so that's all about keys, primary key, foreign key, composite key, and also candidate keys. Okay, and I'll stop here. I'll continue with the first normal form, second normal form, and third normal form with the coming up videos. Thank you, class.